All right. Yep. Good morning, all. Welcome to the demo session for AWS Data Engineer. Okay, so today I'll be discussing about some of the fundamentals of data engineering, and then we'll try to deep dive into what are the roles and responsibilities of a data engineer, and I will also try to show some of the architectures of data engineering projects using AWS, right? Uh, okay, let's start with some fundamentals of data engineering. And first of all, I just want to start with like the very basic thing that is called data. So what is data? Okay, let me share my screen. Yep. So what is data? So if you go to Google and if you search for what is the data, right? So what Google says is data is a collection of raw, unorganized facts, figures, or symbols, such as numbers, words, observations, or measurements that can be processed to provide meaningful information. Okay. So basically, the data, it can be of any form. It can be numbers, it can be characters, it can be symbols, it can be pictures, it can be videos, anything that is in a raw format that is called as data. Now, we will talk about like what are the types of data we have. We have two types of data. One is the qualitative, which is we call this as categorical data in general, and quantitative, which is we call it numerical in general. Okay. Again, this qualitative data, these are further divided into nominal and ordinal. Okay, so which we can categorize. Let's say a gender, man, male and female, right? So that is kind of a categorical data. Even very basic example. So when it comes to the quantitative, it is a numerical. So let's say height of a person or weight of a person or heart rate, right? That is called as quantitative data in general. Okay. So if you
Yeah,
see
sorry
the
for the interruption.
yeah,
Yeah, can you please allow my friends? They are actually there in the lobby.
is it okay? Um, see when here. Can you ask your friends to rejoin again? I should
Okay.
see. Okay, I think almost everyone has joined. All right. So as I was discussing about what is the data and different types of data here, right? So the next thing is like why is data-driven decision making important? Okay, so but before that, I just want to give some context overview about like why companies are so obsessed with dealing with the data and why they are spending good amount of millions of dollars in setting up these data teams like data engineering teams, data scientist teams, and data modeling teams, and everything. Data analyst team. Why? Because so in the 21st century, and or maybe you can say trends of last 10 to 15 years, time, right? So you see the data for each and every company has grown gradually. So now how the data has grown gradually, that is because uh, the companies need to sold the products and they have its data and they will have the customers and now they want to understand the customer behavior in the market, right? So how the customers are responding to the existing products and how they can respond when a new product is launched into the market, right? So this is something, the companies are attracted towards uh, s- to spend some money and in time as well to understand how their companies are performing in the market. So let's take an example of this Flipkart big billion days that happened in the last month, or probably in the middle of this month, right? So I think that big billion days season was like almost like 10 to 15 days. I mean, this is subject to correct if I'm wrong. Uh, so if you see that a large number of products are being sold from the Flipkart's website or application or mobile application, whatever it is. And uh, and I think the prices of the products, if you say, they gave some 10% discounts or they gave some offers, plenty of offers on those products. So how they have set up those prices. So all these things are done by the data team who is very conscious about the products and the prices, and they also try to understand the customer purchase behavior, right? So based on that, they have raised their prices on the discounts itself. And there are also certain factors. Let's say the Flipkart Big Billion Days is done, right? By now. And now the Flipkart wants to understand their customer behavior from the recent sales to customer, right? So that it can try to understand the trends of that particular customer's purchase behavior by analyzing the data. Let's say like, 10 customers bought iPhone 16 and 15 customers bought, Google Pixel 9a or 9, something like that. By using this data, uh, they want to understand like what are the products you know, that got, completed in less than 1 day. Right. So why Flipkart is trying to capture all this data? Because it will use this data to try to analyze the trends and it will use this funds for upcoming big billion days sale. I'm just giving some very high level, very basic example here. So this is where the data plays a bigger picture here. So but you need to cue the trends, right? You need to cue that trends, and we just learned that how what is data. Data basically, it can be anything, but in a real raw form. So it should be analyzed, it should be processed, it should be transformed to understand the trends in the data, right? And that's where these data teams comes in picture, where the data analysts, data engineers, data scientists, machine learning engineers, deep learning engineers, everything. So that entirely depends on the complexity of the project, the complexity of the business outcome that the company is trying to solve. All right. So yeah. So I just try to get some overview here. So what is this? Why data driven decision making important? Because continuing business grow.
You can't see your screen.
Hello,
You can't see your screen.
is it? Oh. Wait. Um, yeah. How about now?
Fine.
Okay. All right. So I'm talking about this like why is data-driven decision making important for companies? So one is the continual business growth. And I just gave an example right now, the Fuka big days. So just want to understand what are we going, what if we going to announce one of the big billion days sale after a couple of months or maybe the same time next year. So what are the products we have to target and what are the trends we have to observe? So I think that one comes into this continual business growth, like try to understand the continual business growth and the knowledge and innovation. Let's say, um, during the big billion days, I think we have seen that, uh, I mean, the server downtime and everything because of the number of customers hitting the application or the web page. So I think this is something actually innovation of a new technology or uh, new solution so that they can solve the questions in a better way. And this is where this knowledge and innovation comes in picture and new business opportunities. Yes. So like, based on the understanding the customer's purchase behavior, so I think there are potential chances for opting for a new business opportunities and better communication, as well, in less errors and less costs. You and revelated adaptability. So even all these things can be happen when the company try to analyze its own data and try to understand trends of coming out of the data. For that, they need a highly sophisticated data team, highly sophisticated technologies, to get these trends and reports, for further use. Okay. And the next thing, so I mean, there are different data roles available in the market. I mean, be it like someone call it as like analyst, someone call it as like uh, I mean, a business analyst. But when it comes to the data, I mean, these are something very important roles, I believe. So one is this data engineer and the data analyst, and data scientist. And machine learning engineer. So data engineer is simply someone who has a direct contact with business, right? So they are the one who are assigned with a big, large sets of raw data, and their job is to extract the data from the various sources, right? Various sources and transform that and load into certain location so that that particular data can be used for further analysis by the data analyst team for report creation or maybe the data scientist to run different models or maybe the machine learning engineer to to train the models, right? So this is a kind of Venn diagram that gives you some interlinking dependencies between the different various uh, data roles. Okay. So here, I mean, in today's topic, we'll try to focus only on the data engineer role. Okay. And later, we'll also try to look at like how the AWS comes in picture for the data engineer role. Okay. Um, so I think when you talk about this data engineer, Ravi, so you need to understand the three V's of data. I'm going to take you through that as well in the next slide. And ETL. So these are the some common terms that you'll be using, the ETL and ELT. And so this is data warehouse storing. This is something, places or storage capacities where we try to store data after we perform the ETL operations or ELT operations. And automated pipeline. Automated pipeline, this is something very important and it is a part of a regular day-to-day practice of a data engineer. Okay, one who is working in a project, right? And the data optimization. Okay, so data optimization is because I mean you'll be given with certain business standards, right? And you will be given with uh, some kind of raw data, and it's your responsibility as a data engineer to uh, go to that data sources and try to understand what is the data, and you need to match or you need to transform that data into you need to transform the data by following the uh, business practices or business procedures, and During the case, you will be exposed to different, uh, you know, different terminologies. Let's say okay, since let's say you are trying to deal with a customer table where it contains some sensitive information, right? Let's say there is a customer data uh, where it has like the customer name, customer address, the customer phone number, or in some cases, in very high level critical projects, we have some kind of other card or social security number, right? And age in date of birth, which are like very, very high sensitive. And now, as a data engineer, you need to be very careful while dealing with the data, right? And so there you have to take care of this, data security standards and data governance. Let's say, okay, as I mentioned, there is a data which is like very critical data and very sensitive data. So data engineer is someone who should be uh, the one to understand like who should access this data because this is sensitive data and you are responsible to add security standards or security protocols according to the enterprise organization, the organization in which you fall work for, and it's your primary responsibility to secure that data. Right. I can put a lot about that, but in the interest of the time, I'll try to jump into the other topics as well. Yeah, this is something very basic or in day-to-day activities of a data engineer role. Okay. So yeah, you try to collect know, some kind of information based on my experience, like what is the data engineer, right? And what is the responsibilities of data engineer? So a data engineer builds and maintains the infrastructure and systems that allow data to be collected, stored, processed, and made accessible for analysis, right? They are responsible for creating reliable and efficient data pipelines to ensure high quality, actionable data is able for data scientists, analysts, and operations process users. Yes. So this whatever the data, right? You process that and it's your responsibility that the data is of high quality and there should not be any data mismatches. And as I told you, that you are the one who set up the standards of security and the governance as well. Or, I mean, there are places where when you talk about like, very big enterprises like in Amazon, uh, Flipkart, Walmart, whatever it is. So what they do, they try to, since they're bigger organizations, when they have a lot of data that is coming from different data sources, like some kind of in terms of like gigabytes or zettabytes or terabytes of data. And then the data analysis, it cannot do that, data storage or data standards or setting up the, understanding sensitive data and trying to set up governance before, I mean, along with that, sensitive data, right? So that's where different teams comes in picture. One is this data modeling team and data governance team where their primary responsible is to secure the data and getting exposure to the internet, some other external sources. Okay. And they are responsible to provide access, certain access like read access or write access or, or maybe basically like, modify access to the teams who actually have a business objective of working with this sensitive data, right? Well, when the level of organization is standing right, then there are certain levels of data engineering teams and teams. So one thing like is talking about data governance team, data security team, and data modeling team. Right? You talk about that in the lecture as well. Like when what if you're working with a wider with an organization. Yes. But here, some key responsibilities, building and maintaining data pipelines. So there is data engineers are responsible for creating automated processes like ETL or ELT pipelines to move and transform data from various sources in a usable form, right? So, yeah, in from various sources, right? It could be anything. It could be like, you're trying to connect with to databases like MySQL or MySQL, or you're trying to work with, or maybe the raw data is in CSV files or Excel files, or it could be in some legacy systems like in mainframe systems, right, which are like 20-year old, right? And in you, as a data engineer, is responsible to fetch the data from those old legacy systems, which is in raw format, and convert that, transform the data into meaningful data, uh, which can be used further for analysis, for analytics. Okay, so there, right? So you will come across uh, these two things, ETL and ELT proteins. All right. And designing and managing data architecture. Yes. Data engineers plays a very crucial roles in creating the data architecture. Okay. They design and operate systems for storing and processing data such as data warehouses or data lakes. I'll show you this architecture, how the a typical data architecture looks like in the end of the session. All right. And ensuring data quality and reliability. Yes, as I told you about the data quality and reliability. Yes. And preparing data for analysis. Yes, the ultimate goal of a data engineer is to prepare the data, whichever he is extracting from various sources. And from that, then you should make that data ready for analysis so that that can be used by the different teams like data analyst teams. They use that data for reporting, creating Power BI reports or reports, or maybe they can create some kind of report so that that can be consumed by the higher level of organization, right? In collaboration, yes. The data engineer, the data engineering team needs to collaborate with multiple teams, right? They work with various business teams. Let's say, I'm taking the example of again Flipkart, right? So Flipkart is a very big organization, and let's say you are one of the uh, team member of a data engineering team working as a data engineer. And your responsibility is to connect with the business partners. Here, business partners is basically the clients or someone who develops application, right? And who owns the data, the data that comes into that application, who owns the data. So you are responsible to connect with that teams or the business, be it be marketing team or sales team or whatever teams, and take the I mean, basically, you take some sort of, requirements from those teams and the data access from those teams, and you perform data transformations, data load, and everything, and you put the data into meaningful format, and then you try to communicate with the data scientists, data analyst teams to understand their data needs, and you provide them this data, this that data to the data analyst and data scientist team, so that you should enable them to use this data from your source, and they can use the data and perform their own, you know, team strategies or, comments based on the business requirements. Right. Um, yes. So these are, I put out these five things. I think these are like very important. The data engineer is the one who really is like, to follow these five steps in their duties. Okay. Next, I mean, when it comes to skills and tools, right? So data engineer is one who should be proficient in any of the language, like data patterns, Pascal or Rust in common. Um, Inside entirely depends on your, business requirement. Okay. Data warehousing and databases. So data warehousing, we'll talk about these items at the end of the session, right? We'll give you more context, like, what are the, what are the difference between data warehouse, database management systems, and data marts when we talk about, all right? In the big data technologies, I mean, if you're doing it some long point of data, then I think these big data technologies is into the similar, like Spark, right? Cloud computing, yes. So I think we use this. I mean, we have multiple options available to cloud. Uh, Maybe like AWS, GCP, Azure, for creating a data engineering project. But I think when every cloud has their own pros and cons, I think AWS stands first in the market. I mean, it is like a stable cloud provider, cloud platform, a provider where it contains all the uh, automated services. You know, I got it. Automated services required for a data engineer to perform the data engineering uh, data engineering tasks on a regular basis with ease, and also the cost factor. All right. Okay. So why we need a cloud computing? Why we need to move to AWS where we have a Python and databases and on-prem, I mean, in the local, right? So as your data grows, right? As your data grows, I mean, you try to uh, extend your database storage from 1 terabyte to terabytes or 3 terabytes in all. But ultimately, you don't, and you have to bear the hosting price as well. Okay, we got to talk about these things in deep when we go into the session. All right. Um, but when it comes to the cloud, right? It is basically only run for hosting your applications in cloud. And, and it will be like very cheap and it will be like very nice. And when it comes to the uh, processing or implementing things, right? It's very helpful, the cloud. All right. And software engineering principles is must done for a strong foundation in software engineering, including skills in building agile and skills is crucial. Yes. I think these software engineering principles is more useful because whenever you are trying to interact with data sources and as a response as a data engineer, you're responsible to fetch the data from those sources into your systems. Okay. There you might need to apply these software engineering principles, right? To get the data, to extract the data and load the data into your systems. All right. So this is how what is a data engineer and what are his or her roles in the daily activities. Okay. Um, yeah, there is just maybe one slide I just want to talk about. As I told, when the enterprise, organization is bigger, the data engineering teams will also get, further divided into different teams. One is this data pipeline engineers and okay, data pipeline engineers and data quality engineer, cloud data engineer, database administrator, data integration engineers, big data engineers, right? So data pipeline engineers. Data pipeline engineers are only responsible to maintain the pipeline. Right? Let's say you have created one glue job and when you also created one Lambda and the data and in the glue job, you specified that, okay, whenever a Lambda gets triggered, right? So try to get this data from a CSV file or Excel file from S3 and you try to process that and apply transformations and and then load the processor data into a Redshift or any data warehouse store. Right? So that is a pipeline, right? I mean, this data pipeline engineers are only responsible to maintain that pipeline only. They just try to fix the pipeline whenever the pipeline breaks because of um, irrelevant issues or sometimes data engineers try to uh, uh, unable to fix the issues, some edge cases, right? This data pipeline engineers comes in picture. And data quality engineer, again, this is one of the data engineering role where they are mostly concerned about the quality of the data. And they will be given with some certain protocols and certain business objectives. And the data quality engineer will try to other when we try to check the data whether these qualities the data is gathering to that given process. Okay. And cloud data engineer is someone, um, who is responsible to look into the, uh, you know, uh, responsible to look into the maintaining the ETL pipelines and creating a new pipelines and trying to get the business objectives done in the cloud. Okay. And database administrator is someone who has all access. I think I don't know about this database administrator. I think the person who is actually working with different data, so databases and who is getting access to the database. I think they can give more clarity about that. but I never worked as a database administrator. And data integration engineers and big data engineers, yes. So they're also part of this data engineering roles. I mean, this slide is basically talking about the different line of data engineering roles that are roles that are available in an organization. And these roles will keep on growing, the number of roles, based on the complexity and the criticality of the data engineering project you are working on. Right? Uh, yes. So we have these three V's of data engineering. I mean, if you remember, I was talking about these three V's of data, right? So these three V's of data. Okay. So this is what the three V's of data is basically volume, variety, and velocity. Volume. Volume, it is talking about the uh, size of the data and size of the data that is available in any of the databases or any of the legacy systems, or it can be the amount of data available in files, local files, flat files, or tables, etc. Okay. Variety. Variety, this is basically talking about the types of data available. One is a structured data, unstructured data, semi-structured data, well, the above. Structured is basically, you can call it as like, tables, rows and columns. Unstructured, you can call it as like videos, or pictures or anything. Semi-structured. Semi-structured, you can talk about like XMLs, JSONs, like, mean, yeah, XML, JSON, HTML, those are called semi-structured data. We can talk about that within the interest of the time. I want to cover other aspects as well in this session. And when it comes to the velocity, velocity is basically the which present real-time stream. So let's say you are working on a data engineering project where you want to show the real-time data to the business or the data analyst or data scientist teams, right? They want the real-time data. So what you do, you create a pipeline and you ensure that data whenever the new data comes into your data sources, then your data will be picked by your ETL pipeline and it processes data and then it will immediately store the data into the processor sources where the data can be used for another data analyst or data scientist things. Okay, so that is like a very real time. Data comes into the input source, your pipeline will pick the data, it will process and transform the data, and then it will store the data into the processor, data source where the data scientist teams can use. Mhm. That is something. Let's say you want to get the sales data, right? Sales data is a particular product at end of every week. So what it will do, at the end of the month, right? Your ETL pipeline will trigger and it will uh, get the last 1 month of data in brief, and it will try to process and transform the data, and it will store that processor breach data into, you know, uh, into the processor of the cases. And again, this data will be used by data analysts and data scientists. Okay. So, I mean, these are the three things that e- e- every data engineer should be aware of. Okay. Next. I mean, these are basically the roles and responsibilities of a data engineer, which I just looked up in this slide, right? So data collection integration, yes, data engineer is responsible to collect the data from different sources and integrate them into the ETL pipeline. Data storage and management as well, yes. The security, data security and the governance also comes into this data storage and management picture, right? Development of data related instruments is basically creating ETL pipelines, okay? And extract transform load process, okay? We'll talk about this stack transform and load in detail in the new slides. I mean, there are two types of these pipeline standards. One is this ETL and ELT. We'll talk about them. And the next thing is provide data access tools, like pipeline visibility. And yes, so this is, I'm sorry, okay, can you use this, right? Yeah. Provide data access tools. So this is the place where you as a data engineer responsible, like who should access this data. Okay, if it's data sensitive, you will try to apply some sort of business logic, and if someone who meets the criteria, then they will be assigned with the access to the data. And product pipeline visibility, and this is where I talked about, um, data pipeline engineers. So as a data engineer, you're primarily responsible to track your pipeline visibility and maintaining the data pipeline. Maybe, I mean, the reason why the pipeline one, I mean, when you create a pipeline, right? Why the pipeline will break? Because as you're dealing with the data can be ambiguous, right? It can be of various types, and sometimes you see you're expecting the data should be in one of the columns. You've seen the data coming in a string format, which is against the data principles you have set up in your data pipeline. Then definitely your data pipeline will break, right? In order to avoid such kind of issues, right? And that issue, the leakage of the data pipeline will cost a lot business in the downstream processes. But in avoid such kind of situations, when if you work as a data engineer, you will be continuously monitoring that data pipelines. That is one primary role. Okay. So these are some essential data engineering terms everyone should be aware of. Like one is this ETL, process of extracting data. I'm not sure whether you are able to see this visible or not, but yeah, extract, transform, and load. It's a process of extracting data from source systems, transforming it to meet business requirements, and loading into target data sources or data warehouses. Data lake. It's basically a raw data repository where you will, various types of data. Okay, data warehouse. It's a structure of structured data source where it's basically centralized repository for filter data, optimize it for analytics and business intelligence queries. And yeah, as a data engineer, your responsibility is to get the data from data lake, right? And you perform the transformations and create a structure in filtered data, and which is very that will be used for different teams. Okay, streaming. I just talked about that. Streaming, it's a real-time processing of data. Like as soon as the data comes into the uh, your input source, you try to get the data based on some event base or some kind of automation. You try to pull the data into your pipeline, and then you try to process the data that you will try to store the data into the data warehouse, which is a structured data store. All right. And pipeline is an automated system, as I talked about, where your entire business logic is written in a technical format, and it is responsible to get the data from source and load that and process that and transform that and then store into the processor format. Batch processing, it's an opposite of streaming. Uh, it's big data into one go. Okay, data mart, and I think these are something pretty advanced topics or terms which data engineers should be aware of. We'll talk about that later, but okay. Uh, let's go to the next slide. Yes. So I'm talking about this ETL process, right? ETL process, it's basically a step where you try to extract data from different data sources, and transform the data and load the data into a data repository, which is a structured data repository where it contains data which is optimized, processed, and filtered data. And this can be directly utilized or consumed by the downstream teams like data analysts or data scientists teams. Okay. And there is one more thing called ELT. So this is ETL and this is ELT. ELT is basically what it will do. It will try to get the data from different data sources. It could be like, Facebook ads, NetSuite, email CRM. Don't worry about these terms, but it depends on entirely the project which you're working on. You try to get the data from there, and you load that data into a single data warehouse, which is a raw data where it contains no business logic or anything. It is basically in pure raw format, and then you apply the transformations, right? So something like, you try to rename a column, or you try to basically you try to it the data. Let's say it is let's take a given column, which is a string, generally, but it is in some kind of bubble format or some uh, raw data, like, it contains some nulls or some kind of irrelevant data in that. You need to pass that column into let's say a string tag. Mhm. You try to remove the irrelevant data from that, right? So this is how this ETL process and ELTs are available in that data engineering stream. Okay. We'll talk about that as well in the course. Okay. Yes. So this is AWS Data Engineering quick ahead. These are some kind of tools that are, or I should call it as like AWS resources that are available now. Uh, AWS, cloud, which which are being used heavily by our typical data engineer. Okay. So, don't worry about these things. We'll talk about that in detail. I just want to give you some sort of like, what are the what are the resources that are available in at one go. So these are the resources that are being used. And yes. So I also want to talk about this. What is the difference between data warehouse and data? Okay. So user for data integration and in the decision making process, user for concrete strategic decisions, right? So these are all some of the uh, these are all some of the um, you know areas where it will try to evaluate the differences between data warehouse and data mart. Okay, so when it comes to sources, it will try to collect data from wide range of sources. Okay, and data mart is basically collect data from small number of sources, usually from the data warehouse itself. Okay, it the input source for data mart is basically a data warehouse. Okay, and size it usually from 100 GB to 1 TB. I mean, these are typical size, but it can be beyond that as well, based on the business requirement. So, have you seen the data warehouse sizes in terms of like TBs, terabytes and petabytes? So, in one of our organization, so, I mean, it varies, okay, because the data is coming from multiple sources. So, we'd be like, as I mentioned, the data might be coming from mainframe systems, data coming from SQL servers, which are not on-prem. The data is coming from Excels or CSVs or fluid files or JSON files or some kind of logs in IoT device, right? Everything that is dumped into this data warehouse, which is a repository which is contains both semi-structured, unstructured, and the structured data, which is not processed. Okay. So implementation time, yes, the implementation process can take from several months to several years. The implementation process usually takes a few months. But this will take months and years because again it also depends on the criticality of a project, criticality of a project, and there are chances where you try to interact with multiple sources and you try to establish connections to the sources to get the data into data warehouse. So that basically typically takes, okay. Yeah. So this is the typical data engineering application looks like. Okay. I think this is the last slide I'm going to talk about. So if you see this right, ingestion processes, I mean ingestion block and storage and processing block. and this consumption block. Right? So ingestion, it is basically it contains all the data, I mean AWS resources that are going to interact with the external systems. Okay, so if you see this is third-party data which is coming. So it is this data exchange. This is one of the resources available in AWS that is trying to connect with this third-party data and try to get the data from here. SaaS partner data. So it could be like, you're trying to get some data from APIs of a SaaS application which is available in an organization, or your organization use that application heavily, right? It is also trying to get the data. And you see these, right? Each block, each one item. So this is a typical AWS resource that is available, and it is responsible to interact with interact with the different data sources. Okay, so if you're talking about like Snowplow, this is an resource that is capable of handling the data coming from APIs or connecting with APIs, right? So similarly like that, all right. And in the storage block, you see this, right? So you're trying to store the data, and parallelly you're trying to validate the data and normalize and transformation data, everything. So I think this entire logic is happening based on the business requirements you get from the business teams. I mean, when in this picture, you can call the business team can be a marketing team or sales team, or it could be something like operations team, right? And here consumption. So this is when you apply the business logics and you try to clean and process the data, you store the data into this consumption group, which is called as load. So you try to load the data in Amazon Redshift, which is a data big data source available, storage source available in AWS, in the SageMaker and Fixit. Fixit is basically reporting tool where it can create some kind of dashboards and yeah, and just to also store the data. Athena, Athena is a AWS resource where you can try to interact with the data by querying the databases. Okay, and yeah. So these are some tips, security levels and monitoring which you can apply to your ETL pipeline so that it can continuously monitor your pipeline, and it can notify if the pipeline is breaking in the middle, right? All right. So I have given um, quick overview of the data, how the data engineering looks like, and what are all the typical data sources available in AWS that will be used by the business teams, I mean, sorry, data engineering teams, right? Uh, okay, I think I'm done with my presentation, but happy to take any questions from you guys if you have anything. Sorry for rushing, but yes, I thought of like covering a lot of things here. All right, thank you. Okay. All right. I'll do one thing. I'll just stop the recording.